Imagine a tiny spark in a vast forest that suddenly ignites a raging wildfire. In the world of cloud infrastructure, a similar chain reaction can happen when a small problem escalates into a massive outage, impacting many users and critical services. This is precisely why understanding and limiting what we call the blast radius is so vital for building truly resilient systems. Limiting the blast radius is critically important for resilience because it contains failures. By designing your cloud architecture to isolate potential problems, you ensure that when an issue inevitably arises, its impact is confined to a small, manageable section of your system, preventing a full-scale domino effect across your entire operation. The core mechanism behind this is preventing failure propagation. Cloud systems are complex, with many interconnected components. A bug in one microservice, an overloaded database, or a misconfigured network setting can quickly ripple through dependencies, affecting services that initially seem unrelated. Limiting the blast radius involves proactively identifying these interdependencies and introducing intentional boundaries. These boundaries create what we call fault domains, which are isolated areas where a failure can occur without affecting other parts of the system. Think of them as firewalls for failures. If one section catches fire, the firewalls keep it from spreading. So, how do you put this into practice? You can begin by segmenting your applications using microservices, ensuring each service runs independently. Another effective strategy is to deploy your infrastructure across multiple availability zones or regions, so that a localized outage in one area does not bring down your entire system. Furthermore, implementing bulkheads, a concept borrowed from shipbuilding, isolates resources like connection pools or threads. This prevents an overload or failure in one area from consuming all available resources and causing a broader collapse. For example, if one type of customer request fails, bulkheads ensure it does not exhaust the resources needed for other types of requests. An interesting insider detail is how chaos engineering plays a role here. It is the practice of deliberately injecting failures into your system in a controlled environment to test your blast radius limits. This proactive approach helps you discover weaknesses before they cause real-world problems. By simulating failures, you can confirm that your containment strategies are actually working as intended and refine them for even greater robustness. This practice often uncovers unexpected dependencies that might otherwise lead to widespread outages. Ultimately, embracing the principle of a limited blast radius translates directly into higher availability and greater stability for your cloud applications. It significantly reduces the financial and reputational risks associated with large-scale outages, providing a more reliable experience for your users. By focusing on containment, you are not just reacting to problems, you are building systems designed to gracefully withstand them, securing trust and operational continuity in your dynamic cloud environment.